Hi guys, again this is Engineer Jason Bautista or Engineer HB for short, and still we're on the topic of chapter 3, which is shafting under machine design, and we're going to solve past board exam problems for combined stresses, power formula, and shaft length versus the shaft diameter. And kakatapos lang natin sa dalawang videos under ng shafting, nag-discuss tayo doon and nag-solve ng 10 problems for torsion, bending, and the angle of twist. So, ngayon, samahan nyo akong magsagot ulit ng mga past board exam problems for this. And before that, we're going to have a little recap for the formulas that we're going to use. So, unahin natin si combined torsion and bending. Combined torsion and bending. So, ayan, meron tayong two formulas. Consider a shaft. Consider a shaft. So, kunyari, meron tayong shaft dyan. So, since this is a combined torsion and bending, pwede rin natin siyang tawagin combined stresses. No? Ibig sabihin si shaft, nakaranas ng parehong torsion tsaka bending. So, nag-bend siya. Kunyari, ito yung bending moment natin. So, meron din siya, nakaranas din siya ng torque. Ayan. So, ibig sabihin, pwede rin palang mag-combine yung torsion and bending on a single shaft at magkasabay. So, meron tayong formula dyan. So, our stress here is 16 over pi d cubed times square root of t squared plus m squared, which is t is for the twisting moment. So, twisting moment. And m, of course, on the bending moment. In order for this, guys, to be remembered easily, we all know that the formula for the torsional stress is 16t over pi d cubed. Pero ang nangyari dito, nagkaroon ng square root. So just retain this 16 over pi d cubed and retain this torque by having this square root of t squared plus m squared. So ganun lang siya alalahanin. No? So that was based on shear stress. How about kapag given is based on normal stress? So our formula is also 16 over pi d cubed, the same as this, times mo lang sa m plus square root of t squared plus m squared. Parang nangyari, nag-retain si t squared plus m squared, kaso nagdagdag ka naman ng additional bending moment kasi may derivation ito. No? Magpo-post din tayo ng another video for that, pero sa ngayon, since this is a review, no, para lang ma-refresh tayo, so ito lang muna. So 16 over pi d cubed times m plus square root of t squared plus m squared, so that was equivalent to our normal stress. So again, this is the normal stress and this is the shear stress. Mas mahaba yung formula ni normal stress. Okay, so that was our combined torsion and bending, or what you call that, combined stresses. So we have here also, no, under ng shafting, yung power formula, which is we are all familiar. So meron tayong tatlo, no, uri ng machinery shaft, which is the main power transmitting shaft, the line shaft carrying pulleys, and the short shafts, or what's you so-called counter shafts. So tatlo yan, madali lang naman tandaan. So as you can see, they are all have a unique formula, which is d cubed. Burahin ko lang 3. Ganda natin 3. So d cubed n divided by constant. So kapag main power transmitting shaft, that was 80. Kapag line shaft carrying pulleys, 53.5 ang ilalim, and the denominator of short shafts or counter shafts is 30. So dadaling tandaan, d cubed n divided by k. So constant mo, 80, 53.5, and 38 for main power, line shaft, and short shafts respectively. So lahat yan na may pinanggalingan na stresses, which comes from the machinery handbook. So ito, 4 KSI, just for additional knowledge. Ito 6 KSI, and ito naman is 8.5 KSI. No? And paano nga pala uli yung unit analysis nito, sir? So ito lahat is for power, for unit of horsepower. So kailangan yung diameter mo is inches daw pag pinasok, and yung N mo or the shaft speed is in RPM. In order for you to have a power in a unit of horsepower, your diameter should be in inches and your shaft speed should be in RPM. So wala tayong metric for this. Kung meron man, kailangan i-convert muna natin lahat sa English, no, kung may given kang millimeter na diameter, i-convert mo muna sa inches. And your power is in HP, so kung tinatanong in kilowatts, saka mo na lang i-convert. Why? Kasi lahat ng derivation nitong power comes from a English unit also, which is on KSI nga, itong mga stresses na itong pinagbasihan. So we have another video for this, no? I will posted sa link kung saan galing itong mga formulas na ito. So madali lang naman. And lastly, we have the shaft supported length versus shaft diameter. So meron tayong L dito and D, of course. Yung L stands for the length. So ginagamit tong formula na to, tong dalawa. Drawing ko lang muna saglit. Length stands for the maximum distance between two bearings. We all know that the shaft also, ayan, may nakakabit sa bearing yan. So, kunyari yan, nakakabit yan. Siyempre may konting hang yan. May konting hang. So kung ito yung bearing mo, ito yung bearing mo. So this is your length here. And of course, meron siyang diameter also. Which is, meron tayong dalawang formula. Shafting subjected to no bending action except its own weight. So walang bending action na naganap sa shaft mo. So ito yung shaft. Pero it is subjected to its own weight. So meron formula and relationship between its length, its diameter, which is equal to 8.95 times d raised to 2/3. So pwede natin siyang write or isulat kagaya nito para mas madali. No? So 8.95 times d raised to 2/3, yan yung relation ng case 1 natin, which is yung shaft subjected sa walang bending pero subjected siya to its own weight. Siyempre, meron pa rin mga pangyayari dyan. And the second case is the shaft subjected to bending action due to pulleys. So kung dito sa first case, its own weight, ito naman due to pulleys naman. Pero ito may bending action. Ito wala. Pero ito meron, bending action due to pulleys. So ang relationship naman niya is length is equal to 5.2 d raised to 2/3 din. So magkaiba lang is yung constant. So just remember the L is equal to K times d raised to 2/3. Dalawa lang naman yung cases mo. Subject to its own weight, so that was 8.95. And due to pulleys, that was 5.2. So ang unit analysis naman dito guys is yung length mo is always in feet, while your diameter is always in inches. In order for you to get the length, kailangan yung diameter mo is naka-inches. In order for your diameter to become inches, of course, kailangan mong naka-feet sila. So ayun, konting recap lang, and ayun, discuss na natin or solve na natin yung mga problems. I will read the first problem. Find the power in watts transmitted by a main power transmitting shaft with a diameter of 65 mm and a speed of 200 RPM. So the question is looking for the power transmitted by the main power transmitting shaft. And we all know that the main power transmitting shaft has a formula of power is equal to d cubed divided by constant. And for main power transmitting shaft, that was 80. In order for you to have your power in horsepower, your diameter should be in inches and your shaft speed should be in RPM. So, ayan, kunin muna natin. So, ang diameter na given is 65 mm. And our shaft speed is 200 RPM. So, wag malilito, no, yung sa small n tsaka sa capital N. Pare lang ng mga speed yan. So, minsan kung ano lang din yung sulat ko, no, na letter N. Pero shaft speed lang naman nire-represent niya for the whole chapter of shafting. So, ayan, kailangan convert muna natin siya sa inches. So, 65 divided by 25.4. And that is 2.56 inches. So, ang power natin should be in horsepower. So, that was 2.56 cubed times speed, which is 200 RPM divided by 80. So, ang answer natin is in horsepower. So, cube mo yung answer mo times 200 divided by 80. So, our answer is 41.9 horsepower. And syempre, ang hinahanap is in watts. I-convert muna natin yung horsepower into kilowatts. We all know that in 1 horsepower, we have the 0.746 kilowatts. And in 1 kilowatts, we have the 1,000 watts. So the answer is 41.9 times 0.746 times 1,000. So the answer is 31,254.87 watts. So meron ba sa answer? So the answer is letter D. So ang pinakamalapit is 31.254. Wala lang decimal. Pero obviously naman siya ang pinakamalapit. So the answer is letter D. So second question naman tayo. What is the diameter of a line shaft that transmits 150 kilowatts at 15 revolutions per second? So this question naman is talking about line shaft. So first question is main power transmitting shaft. So this is all about naman na line shaft. So ang hinahanap is diameter. So syempre, formula lang naman ng power ang panggagalingan ng mga uri ng shaft ito, which is power is equal to d cube n divided by constant, and that is 53.5 for a line shaft, divided by 80 naman kapag main power transmitting, and kapag short shaft is 38. So meron namang given, no, na 150 kilowatts. And syempre kagaya ng first question, we need to convert it on horsepower first. So 150. So in every 1 horsepower, there's 0.746 kilowatts. So that will become 201.07 horsepower. And yung N natin is 15 revolutions per second. We all know that we need to convert it first on 15 or on revolutions per minute. So it will become 15 times 60 kasi 60 seconds is equal to 1 minute. So 15 times 60, so that was 900 RPM. So, ayan, direct sub. Naka-horsepower na si power natin. Naka-RPM na si shaft speed. So, ang diameter natin dito ay expected to be in unit of inches. So, our power is 201.07 horsepower is equal to d cube n divided by 53.5. So our diameter is 201.07 times 53.5 divided by 900. Cube mo yun. And the answer is 2.286 inches. Pero ang choices is in millimeters, so we need to convert it first. So we all know that in every inch, there's 25 sulat. There's 25.4 millimeter in every inch. So times mo lang yung 2.286 ng 25.4, and the answer is 58.07 or 58.1, which ang answer ay ayun, nasa letter A. So ayun, madali lang naman kasi it is always direct sub pag ganitong problem. Ang pinaka medyo makukulitan ka rito is yung unit conversion. So be aware of all the unit conversion. That's why you need to know the basic. No, kasi ito direct sub lang sana, kaso iba-iba ng unit. So yun yung challenge mo. Pero pag na-practice mo naman yan and you memorize all the basic conversions, so wala nang problema sa ito. So that was the answer, 58.1, which is letter A. Proceed tayo sa third question. So a 3 inches diameter short shaft, so short shaft naman to, carries 2 pulleys close to the supporting bearings. How much horsepower can be transmitted at 280 RPM? So si short shaft naman to, and we all know that for the short shaft, power is equal to d cube n divided by 38. Basta si power mo is in HP, ang diameter mo is in inches, and your n should be in RPM. Okay, so ang tinatanong, how much horsepower? So meron na tayong given agad na n is equal to 280 RPM. And we have this diameter here which is in inches na. So that was 3 inches. So matik, it is a direct substitution problem. So it will become 3 cube times 280 divided by 38. So it will become 3 cube times 280 divide 38. So that was 198.95 horsepower. And all the choices naman is in horsepower. Kailangan lang natin humanap ng malapit. So we have the 180 here, 200 here sa letter B, which is malapit. 190 here, 210 here. So ang pinakamalapit is 200 horsepower. So it is rounded up to the nearest 100. So the answer is letter B. So the answer is letter B. Okay, so proceed tayo sa fourth question. A 16 feet steel line shaft has no bending load except its own weight. What power in horsepower can the shaft deliver it at a speed of 200 RPM? So meron daw tayong given line shaft which is a 16 feet steel and has no bending load except its own weight. No? So kung babalikan natin kanina, meron tayong formula na kapag may dalawang cases tayo. So the first case is no bending load except its own weight. So merong relationship si length and diameter. So that was L is equal to constant times D raised to 2/3. So we all know that kapag no bending load except its own weight, so that was equal to L is equal to 8.95 cube root of D squared or 8.95 times D raised to 2/3. So ang kailangan length mo is in feet para magkaroon ka ng diameter in inches here or vice versa. So ayan, meron tayong 16 feet here is equal to 8.95 D raised to 2/3. So ang makukuha nating diameter is 16 feet divided by mo ng 8.95. Raise mo ng 1.5 kasi naka 2/3 ka sa kabila. So the answer is 2.39 inches. So diameter ba ang hinahanap? Hindi. Ang hinahanap is what power in horsepower. Can the shaft deliver at speed of 200 RPM? So our speed is in 200 RPM. And we all know that the given type of shaft is a line shaft. Meron niyang formula na power is equal to D cube and divided by constant which is 53.5. No? So meron naman tayong diameter in inches na rito and we have the RPM here and everything will be direct sum at this point. So it will become 2.39 cube times the RPM of 200 divided by 53.5. So our power is 2.39 cube times 200 divided by 53.5 and we have this 51.05 horsepower. So meron kayong sagot sa choices 31, 24, 51. So ayan. The answer is letter C, 51.1 horsepower. Okay, so proceed tayo sa last question. The axle of a heavy-duty tractor transmits 120 kilowatts at 600 RPM. It acts as a cantilever supporting a load of 280 Newton rudder located 60 cm or 600 millimeters from the fixed end. The allowable normal stress is 137 megapascals and the allowable shear stress is 62 megapascals. If the axial load is negligible, find the axial diameter. So the scenario here is that the axle of the heavy duty tractor, no, acts as a cantilever. So meron tayong cantilever na drawing dito. Kunyari yan yung axle mo at yun yung cantilever, no? It acts as a cantilever supporting a load of 280 newtons located 60 centimeter from the fixed end. So this is your fixed end and this is your 60 cm. So convert na natin siya ng mm which is 60 cm is equal to 600 mm because 1 cm is equal to 10 mm. So alam niyo na yan pero mas maganda, nire-review natin. It is worth repeating. So ang sabi, the allowable normal stress is 137 megapascals and the allowable shear stress is 62 megapascals. If the axial load is negligible, find the axial diameter. So sabihin natin ito yung diameter. So this is a case, syempre, ng combined stresses which is yung axial load is negligible, tamang-tama. ang diniscuss natin sa formula kanina, yung little recap natin is just for combined stresses of torsion and bending. So, kapag sa shear stress daw ang basis, meron tayong 16 over pi d cube square root of t squared plus m squared. So, ibig sabihin ng t, your twisting moment, and your m is bending moment. Walang problema sa unit analysis niyan kasi in-square mo naman siya in square root. So, it will be back on its own standard unit. And kapag normal daw, ang basis, normal stress, still 16 over pi d cube multiply by m or bending moment plus. Of course, retain your t squared. T squared plus m squared. Alright, so dyan pa lang, maaari nating malaman yung diameter, which is yung hinahanap ng problem, your axial diameter. And syempre, bago yon, meron naman tayong given na stress. Ang problema, wala tayong given na twisting moment at bending moment. But way back on the first sentence, ang sabi, the axial of a heavy-duty tractor transmit 120 kilowatts. So that was 120 kilowatts. And speed of 600 RPM. So N na lang ni small para hindi malito. So that was our 600 RPM. So matik yan kapag may power si shaft at may shaft speed, meaning pwede natin makuha yung torque. So ibig sabihin 120 kilowatts is equal to torque times 600 RPM divided by 9.549 times 10 raised to 6. So our torque here will become 120 kilowatts times 9.549 times 10 raised to 6 divided by 600. So that is 1909 800 Newton millimeter. Okay. So meron tayo na torque. Ibig sabihin, check na si torque. So how are we going to get the bending moment? So we all know na kapag cantilever ang scenario, it is just the force times length. From the to the pre-end. And we all know that the force applied is 280 newtons times 600 mm. So yun yung kahalagahan ng kino-convert mo agad yung cm mo dito in mm kasi naka-newton mm si torque. So dapat si bending moment mo rin. So 280 times 600, so that was 168,000 Newton mm. So medyo lamang ng malaking value si torque. Pero ang mahalaga, kukunin natin diameter. So pwede nating makuha yung diameter here. Kasi given na yung stress and meron tayong torque and bending moment. So unahin muna natin si shear stress. Si shear stress. So ito yan. So that will become 62 equal to 16 over pi d cube. So megapascals dapat lahat to guys kasi Newton mm pa rin yung torque mo dito kahit i-square mo yan, naka-square root naman. So it will be back to Newton mm. So that was 1909 800 squared plus 168,000 squared. So answer is ship store A muna yung torque mo kanina, which is 1909,800. So sabihin natin ship store A, not a choices of A, ship store A. Lagyan natin ship store A. And dito naman sa M, pwede nating ship store as B. Ship store B. Yan, ship store B. Palitan lang natin yung mga hindi magbenta ng sulat. Yan. So our diameter here is, so pwede mong sabihin A squared plus B squared is square root nun times 16 divided by pi divided by 62. So cube root nun. So the answer is 54 mm. Kapag ang basis mo raw is shear stress. And how about if your basis is normal stress? So pwede natin sabihin that it is equivalent to 137 is equal to 16 divided by pi d cube. Ba't gano'n nagdidikit-dikit? Excited lang tayo magsulat. Siguro. Times bending moment. So sabihin na natin b squared siya plus square root of a squared plus b squared. Para magamit mo yung shape store. Makakatulong sa inyo yan, guys. So ang diameter natin is, kasi halimbawa sa board exam, konti lang kasi ang scratch dyan eh. Your scratch is very limited. So it's better kung naka-store na yung mga data mo. So tatandaan mo lang na yun. Huwag ka lang talaga magkakamali. So unahin mo natin si b. So b squared plus square root of a squared plus b squared. Kita ba? Hindi. Kasi meron tayong background picture. Kunyari sa classroom. Miss ko na rin ang classroom. Tama ba? So ang a squared plus b squared. Mali. Yung b natin pala ay wala ng squared. Nagulat ako lumaki. So ayan. So wag na kayong magalit. So a squared plus b squared square root nun plus b times 16 divided by pi divided by 137 and cube root nun is this 42.63. So it is the same, no? Sa previous questions natin, na kapag dalawang basis, kailangan hanapin mo lagi mas malaking diameter in order for your stresses not to be exceeded. Kasi once na nilitan mo yung diameter, lalagpas yan dun sa allowable stress. So that's why kailangan mas malaking diameter ang pipiliin natin. So 54 versus 42, of course, the correct answer is 54. So ang nasa choices, it is letter A. And makikita naman, obviously, 42 is out of the choices. Basically, or automatically, the correct answer is 54 mm. So ayun guys, nakapag-solve tayo ng 5 problems for the part 3 of shafting, and salamat sa pagsama sa akin for this problem solving. Guys, ang tanging hiling ko lang is to continue support our FB page, which is Derive, and itong YouTube channel natin by Truly Yours Engineer HB. So ayun, I hope may natutunan kayo, and see you sa mga next videos natin. Yun lang guys, please subscribe po, and God bless sa inyong review. Thank you. See you.